Hello everyone, welcome to Chemspires. In this video, we'll look into problem number 7.8 from 11th Standard Chemistry NCERT textbook. Let's read out the question. The question is 13.8 grams of N2O4 was placed in 1 liter reaction vessel at 400 Kelvin and allowed to attain equilibrium. So this equilibrium reaction is N2O4 gas in equilibrium with 2NO2 gas. The total pressure at equilibrium was found to be 9.15 bar. Calculate Kc, Kp and partial pressure at equilibrium. Come on, let's solve it. We already know that PV is equal to nRT. And the given data are total volume, which is given as 1 liter. We know that molecular mass of N2O4 is 92 grams. Number of moles can be calculated by the formula given mass by molar mass. The given mass of N2O4 is 13.8 grams and the molar mass of N2O4 is 92 grams, which is equal to 0.15 moles. So N is 0.15. Gas constant R is 0.083 bar liter mole inverse K inverse. If all other values are in SI units, we can use the value of R as 8.314 joule Kelvin inverse mole inverse. But here we will use the value of R as 0.083 bar liter mole inverse Kelvin inverse. And the temperature is given as 400 Kelvin. Let's substitute all these values in the equation PV is equal to nRT. And solving, we will get the answer of P as 4.98 bar. This is the value of pressure. So now we will write the equation of equilibrium reaction, that is N2O4 in equilibrium with 2NO2. Here we have found out the pressure, that is initial pressure, as 4.98 bar. So at initial conditions, N2O4's pressure will be 4.98, and since NO2 is the products, initially the pressure will be 0. And at equilibrium, if we assume that X is the amount of decrease in the pressure, then at equilibrium the pressure of N2O4 will be 4.98 minus X bar, and the pressure of NO2 will be, that is, since there is 2 NO2, we will write 2X bar. And hence P total can be calculated as the pressure of N2O4 plus pressure of NO2. So here total pressure is given in the question as 9.15, and we know that the pressure of N2O4 is 4.98 minus X and the pressure of NO2 is 2X. So solving, we will get the value of X as 4.17 bar. So now using this X value, we can find out the exact value of partial pressures of N2O4 and NO2 at equilibrium. So partial pressure of N2O4 is 4.98 minus X. So here 4.98 minus 4.17, which is equal to 0.81 bar. In the same way, partial pressure of NO2 is 2X, which is equal to 2 into 4.17 equal to 8.34 bar. From this, we can calculate the value of Kp. So here for this reaction, Kp will be partial pressure of NO2 power 2 by partial pressure of N2O4. So we'll substitute the values, that is 8.34 square by 0.81, which is equal to 85.87 as the answer. We know that Kp is equal to Kc into RT power delta N. So Kp is known, that is 85.87 equal to Kc, which is unknown, and R is known, that is 0.083, and temperature is also known, that is 400, and delta N, which is the number of moles of product minus the number of moles of reactant. So in this reaction it will be 2 minus 1, which is equal to 1. So I have written it as the power, and we'll get the answer of Kc as 2.586, which can be approximated to 2.6.